Hello viewers, in the previous programs we have discussed electronic components in detail. Now in this program we are going to discuss the testing of electronic components using a CRO. Now here you will find all these electronic components have been brought: the resistors, the potentiometers, the capacitors, the inductors, the diodes, the Zeners, rectifiers, transistors, UJTs, that is unijunction transistors, SCRs, silicon control rectifiers, and triacs. Now when we see these components on a CRO, we have to know 2-3 basic things. Let us see. First, any component can be either open or short, and if it is not open or short, it has to be healthy. If a component is open, the CRO is going to show you a horizontal line. If it is short, the CRO is going to show you a vertical line, and if otherwise, that means healthy, it will depend from component to component what type of figure you are going to get on a CRO screen. Now we will discuss them one by one. I take the example of resistors first. Resistors. If a resistor is seen on a CRO or tested on a CRO, we will have an inclined line like this. It shows, it depends, the inclination of course depends on the value of the resistor. There is no question of short, and if it is open, it will be a horizontal line. Now if it is a potentiometer, that is a pot, in case of potentiometers, again you will get a line like this, inclined line, but the inclination of the line will keep on changing when I change the value of the resistor, because potentiometer is nothing but a kind of variable resistor. So once you change the value of the potentiometer, this inclination line of the inclination will change, and that will show that the value of the resistor is changing. In case of a capacitor, you will find that you will get a loop like this when connected on a CRO. You will get a loop like this, and if you do not get a loop like this, if you get a horizontal line, that means the capacitor is open, and if you get a vertical line, it means the capacitor is short. In case of an inductor, you will get again a loop something like this, and the loop will depend on the value of the inductor. Here also in case of capacitor, the size of the loop will depend on its value. So these are some of the tests, the wave shapes which you are going to get if you connect them on a CRO. In case of resistor, you will get an inclined line. In case of a potentiometer, again an inclined line, but this inclination of the line will keep on changing as you change the value of the resistor. In case of a capacitor, if it is healthy, you will get a loop like this. If in case of an inductor, you will get again a loop like this, and if any device is open, you are going to get a horizontal line. If any device is short, you are going to get a vertical line. So we are now going to see all these components while checking it on a CRO. But before I go for the checking, I would like to tell you that you have to keep this CRO in component testing mode. If this facility is not there in the CRO, you will not be able to conduct these tests. So first of all, the CRO must have the component testing facility, and then you have to keep it in component testing mode. What do you do for that? Look here, there are two sockets here. These are the CT in sockets, means component testing sockets. You have to connect these leads to these sockets and then press this component testing button so that the CRO becomes in CT mode, component testing mode. After that, any device which is to be tested will be connected across the leads and the shape will be demonstrated on the CRO. Now let us see, I am going to request Mr. Singh to demonstrate before you the testing of all these components. Mr. Singh, please. First of all, he is inserting the leads in the CT in sockets, and now he is pressing the button. So the CRO is in CT mode. Now first he is going to test the resistor. He is connecting the resistor across the leads. You see an inclined line is coming. An inclined line is coming means the resistor is healthy. Okay, Mr. Singh. Now let us see a potentiometer pot. He is connecting the two variable terminals across the leads, and now he is going to vary the potentiometer. You see the line, inclination of the line is changing. What does it mean? Yes, it shows that the potentiometer is healthy and it is going from its 0 value to its maximum value. Of course, this is an open sort of thing, that means it has the maximum value, and the vertical was almost 0, that is short. So the potentiometer shown here is a healthy one. Now a capacitor, it is a dielectric capacitor, and he is connecting between the two leads. A loop is coming. This is the loop which shows that the capacitor is healthy in nature. You can reverse the polarities. Yes, again the same loop is being seen. So it confirms that the capacitor is healthy in nature. Fine. The inductor, of course, in place of inductor we are going to show a miniature transformer. We are going to use it as an inductor coil, and when is connect, this loop is coming on the CRO screen, and this shows that the inductor coil is healthy. Fine. Thank you. So after taking up the resistors, the potentiometers and the capacitors, we are now going to take up the diodes, Zener's and the rectifiers. The diodes, of course, you know that the diode is basically a rectifier and it is a unidirectional device. So it can be either forward biased or reverse biased. If I keep it in forward biased and place it on a CRO, what will I get? I would get a figure like this. This is the figure for a diode when kept in forward bias condition, and if I reverse it, that is reverse bias condition, I would get a figure like this. The same diode will give you a figure on CRO like this when it is reverse biased. So this is the case of a diode. Of course, if the diode is short, you are going to get a vertical line. If the diode is open, you are going to get a horizontal line. Now in case of a Zener, you know that Zeners are all basically diodes and they are tested on reverse biased. They will also give a figure like this only, so it will be tested on reverse bias, and a figure like this will be obtained when the Zener is kept on reverse biased. This figure will be obtained on a CRO when the Zener is healthy, and otherwise you may get a short Zener or you may get an open Zener also. Then the case of a rectifier. course rectifiers, I would like to explain it here first. You see here is a rectifier in my hand, and when I say it is a rectifier I mean a bridge rectifier. You see there are 4 terminals coming out, 1 2 3 4, and the first and the third terminal, if you see it minutely, AC signals have been printed, sinusoidal signal has been printed. What does it mean? That means the AC input has to be given on pin number 1 and pin number 3, and pin number 2 and pin number 4 you will find that there are positive and negative. That means this will give you the output. The output will come out from pin number 2 and pin number 4. So rectifier is basically a bridge rectifier, and if you again check it on a CRO, you will get again a forward bias condition waveform. When a rectifier, that means a bridge rectifier, is tested on a CRO, if it is healthy you will get a figure like this, that is a forward bias condition, and if you get such figure you will be assured that the rectifier is healthy. Now again we are going to check all these components on the CRO. So he is going to press the button, so the CRO is now in CT mode. Okay. Now let us one by one check the components. First of all he is checking a diode, and he is giving a forward bias. This is a forward bias condition for a diode, and the figure is obtained on the CRO screen. And what does it mean? It shows that the diode is healthy. Reverse it please. On reversing, the diagram has also reversed and it shows that the diode is alright. Okay. Next, Mr. Singh, you can perhaps check an LED also.
Yes, sir.
Fine. Yes. So this is a forward bias condition and the figure is obtained. Reverse it please. On reverse biased also, the figure is also reversed. So LED is healthy in nature. That is the conclusion. Fine. Next, perhaps Zener. Okay. Connect it. Zener is to be checked in reverse bias condition only.
Yes, sir.
Yes. So you are getting a figure like that. It shows that the Zener is healthy. Fine. And now a rectifier. Okay. And now in case of rectifier, since the input is AC, we will only see the output, that is between terminals 2 and 4.
Yes, sir.
Yes. So you are getting a figure like this. This shows that the rectifier is healthy. Thank you. So after taking up resistors, potentiometers, capacitors, inductors, diodes and Zeners, rectifiers, we are going to now take up and examine the transistors and the unijunction transistors. Let us see a transistor first. You all know that in case of a transistor there are 3 terminals, the base, the collector and the emitter. So we will check the figures of the device on a CRO between BC, that is base and collector, between base and emitter, and between emitter and collector. The figures what we are going to get here is, in case of base and collector, you will get a figure like this, which resembles the one which you got for a diode forward bias condition. Between base and emitter you will get a figure like this. Like this you will get a figure if the transistor is healthy, and between emitter and collector you are going to get a figure like this, a small kink here and then a vertical line. Of course many times you will find that this kink will not be obtained on the CRO, you will get a figure like this, that is a forward bias diode condition. If you get between base and collector a figure like this, between base and emitter this, between emitter and collector this, then rest assured that the transistor is healthy in nature. And if you don't get it, if you get a horizontal line or a vertical line, in that case, in case of horizontal line it will be open, in case of a vertical line the transistor will be short. So this is all about transistors. And then comes the unijunction transistors, that is UJTs. Now in case of UJTs, perhaps you remember that we again have 3 terminals, but the terminals here are emitter, base 1 and base 2. These are the 3 terminals. I will repeat, emitter, base 1 and base 2. So if you check the device on the CRO between emitter and base 1, you will get a figure emitter and base 1. You will get a figure like this, and if you check it between emitter and base 2, again you will get a figure like this. So if I will repeat, in case of a UJT, if you have between emitter and base 1 UJT, if you have between emitter and base 1 a figure like this, between emitter and base 2 again a figure like this, this will indicate that the UJT is healthy in nature. Otherwise it can be open, or it can also the transistors and the UJTs while we see it on case of a CRO. Now I request Mr. Singh to demonstrate it on the CRO. So first of all he is to put it in CT mode, he has pressed the button and now he is to balance the beam. Okay. Now the transistor, he is going to check transistor, and for transistor he will check it between base and collector. Okay. Between base and collector, is it? Yes. So he is getting this pattern. So this shows that the transistor is healthy. Okay, change it between base and emitter. Let us see. Again he is getting this type of curve, very fine. Then change it between emitter and collector. Yes, let us see what do you get. That is it. See, you are getting that sort of curve which I discussed earlier, but that kink is slightly missing and the line is smaller. It depends on the values, but this clearly indicates that the transistor is okay, it is healthy in nature. Thank you. The next one. Okay. Check the UJT. First you have to connect it between emitter and base 1 and then emitter and base 2. Okay. So he is connecting it between emitter and base 1. Emitter and base 1, this type of, yes, this type of curve you are getting. Now check it for emitter and base 2. You see, same type of curve as I told you earlier, same type of curve you are getting, but it indicates that the UJT is healthy in nature. Thank you. So now we are going to take up the next group, that is the Thyristor group of components. There is the SCRs and the triacs. Let us see. In case of an SCR, you know that how many terminals are there? Do you remember? Yes, there are 3 terminals. The anode, of course, I will write it first, SCRs, and you have the terminals as anode, cathode and gate. You remember it. Okay. So in this case also we have to check the terminals very minutely, and then we have to connect the device on the CRO between G and K. If you connect between G and K, you will get a curve like this, a wave pattern like this. This is of course between G and K, and if you get such a figure on the CRO screen, it is ensured that the device is healthy. If it is short, what will you get? In case of short SCR, you will get a vertical line. In case of an open one, you will get a horizontal line. Now let us see what will you get in case of a triax. Okay. Triax. Here also there are 3 terminals. The terminals are T2, T1 and gate. Of course, this is main terminal 2, main terminal 1 and gate, you remember it. And if I connect the device on the CRO between gate and terminal 1, you will get a figure like this. This is between G and T1. If you obtain a figure on the CRO screen like this, when you connect it between G and T1, that is gate and main terminal 1, it is ensured that the device is healthy. And if you do not get it, you may get either short or open. Now, let us check these components again on the CRO. Yes, Mr. Singh?
Yes, sir.
Okay, you put it on CT mode. Yes, that is the CT mode. Balance it and then see. First you are checking an SCR. Okay. You see, this is, he has connected between G and K, that is gate and cathode, very clear, and the curve is obtained on the CRO screen. It shows that the SCR is healthy. Okay. Next is triac, and in case of triac you will see it between G and T1. You see, just now I discussed this type of figure you will get, and what does it mean? It means the triac is healthy in nature. Okay, fine. Now you replace it. Now you can check some of the damaged components also. You see, incidentally both these components are power diodes.
Yes, sir.
They are power diodes. Okay. Now you are getting a vertical line. What does it mean? You see, this shows that this particular device is short. Okay. Now let us check another one. The second one, that is also a power diode.
Yes, sir.
Okay. And in this case you are getting a horizontal line. What does it mean? It means that the device is open. That's it. Very good. Okay, thank you, Mr. Singh. So viewers, we have seen the different electronic and power electronic components. We have discussed their testing both physically and electrically. In the few more programs, we are going to discuss the applications of all these components, especially the thyristors. Thank you.